Have you ever wondered if moonlight is different from sunlight? I mean, we've all been taught that the moon shines because its surface reflects sunlight. But what if there's more to the story? What if moonlight isn't just reflected sunlight, but something else entirely? Today we're diving deep into a fascinating hypothesis that suggests moonlight might be fundamentally different from the sunlight we see during the day. We'll be exploring a variety of experiments and observations that could challenge our conventional understanding of how the moon shines. Get ready to put on your thinking caps and embrace the spirit of scientific inquiry as we embark on this cosmic journey to unravel the mysteries of moonlight. Our first experiment is surprisingly simple, yet potentially groundbreaking. We're going to take two identical thermometers and place one in direct moonlight and the other in a shaded area, both exposed to the night sky. Now, if moonlight is just reflected sunlight, we'd expect both thermometers to show similar temperature readings. However, if the thermometer in the moonlight shows a lower temperature, it could suggest that moonlight might possess fundamentally different properties compared to reflected sunlight. Let's see what happens. We're all familiar with how mirrors reflect light. Shine a light pointer on a mirror and you get a bright focused reflection, right? Now let's compare that to moonlight. Moonlight seems softer, more diffuse, almost like a glow stick's electronic light rather than a simple reflection. This difference in how moonlight behaves compared to a typical reflection raises intriguing questions about its true nature. Could it be that moonlight is generated differently than just being bounced off the lunar surface? Time to bring out the polarized sunglasses. Or if you're feeling fancy, a polarizing filter will do the trick. When we look at sunlight through a polarizer, the intensity of the light changes depending on the angle. That's because sunlight is polarized, meaning its waves vibrate in specific directions. Now let's do the same with moonlight. If moonlight behaves like typical reflected light, we'd expect to see similar polarization effects. However, if we observe little to no polarization in moonlight, it would strongly suggest that moonlight is not simply reflected sunlight, but might be electronically emitted light, much like the light from your computer screen. Remember those glow-in-the-dark toys we loved as kids? They absorb light energy, and then re-emit it slowly, creating that cool glowing effect. Well, there's a hypothesis that lunar dust might behave similarly. Imagine lunar dust absorbing high-energy radiation from the sun throughout the day. As the lunar surface plunges into darkness, this energized dust could then release the absorbed energy as electronic moonlight, much like our glow-in-the-dark toys. It's a fascinating idea that could explain why moonlight appears different from regular reflected light. Let's set up another experiment to understand the potential differences in the nature of light. We'll shine a regular heat lamp onto a metal surface and observe how the surface heats up. This demonstrates how traditional incandescent light carries heat energy. Next, we'll shine a fluorescent light on the same surface. Notice how the surface remains relatively cool. This is because fluorescent light generates less heat. If moonlight behaves more like the fluorescent light in this experiment, remaining relatively cool, it could further support the idea that moonlight is a different kind of light, perhaps generated through electron excitation. For this experiment, we'll need two black and white photographs of the same scene, one taken in broad daylight and another taken under a long exposure to moonlight. By comparing the brightness levels and shadows in both photographs, we can analyze if moonlight's spectral distribution, meaning the range of colors it contains, matches that of sunlight. If the moonlight photo shows a different distribution of light and shadow compared to the daylight photo, it would further suggest that moonlight might not be a simple reflection of sunlight but could be enriched with electronically generated light. Spectroscopy is like fingerprinting light. It allows us to analyze the specific wavelengths present in different light sources. By using a spectrometer, we can compare the spectrum of moonlight to the spectrum of sunlight. If moonlight is purely reflected sunlight, their spectra should be nearly identical. However, if we find subtle but significant differences in their spectral lines, it would be compelling evidence that moonlight undergoes some form of energy transformation on the moon, possibly through the interaction of solar radiation with lunar electrons. As we've explored throughout this episode, several lines of evidence suggest that moonlight might be more than just reflected sunlight. The potential differences in temperature, reflection behavior, polarization, and spectral signature all hint at a more complex and intriguing phenomenon. While more research is needed to confirm these findings, the idea that moonlight could be a type of electronic light, generated by the interaction of solar radiation with lunar electrons, opens up a fascinating new perspective on our celestial neighbor. It reminds us that even seemingly simple phenomena can hold profound mysteries, waiting to be unraveled by curious minds. The experiments we've discussed today represent just the beginning of our exploration into the true nature of moonlight. By carefully designing and conducting further research, we can gain a deeper understanding of the fascinating interaction between sunlight, the lunar surface, and the light that reaches our eyes here on Earth. The possibility that moonlight might be electronically generated challenges our assumptions and reminds us that the universe is full of surprises. It highlights the importance of constantly questioning, exploring, and pushing the boundaries of our knowledge. So the next time you gaze up at the moon, remember that its gentle glow might hold secrets far more profound than we ever imagined. Stay curious, keep exploring, and never stop questioning the world around you.